So we ended up with the stoichiometry roadmap, and I hope you've watched already gas stoichiometry videos, parts 1, 2, and 3. This time I'm going to give you some challenge problems in which I'm going to guide you in between the challenge problems so that you'll know based on the roadmap how you're going to approach the problem. Take note that this is just repeated for the stoichiometry roadmap in which the volumes of either gas A or B are inserted into the roadmap, in which you have two choices. If it's at STP, you can just readily use 1 mole is to 22.4 liters, or you may just use the ideal gas law, PV is equal to nRT, in which the R has to be remembered. It's 0.0821 liter atmosphere per mole Kelvin. Now we're ready for problem number 1. Problem number 1 talks about the decomposition of your ammonia gas. Now take note that your chemical equation is not balanced yet. So before beginning with any stoichiometry problem, I want you to always take note whether the equation is balanced or not, and if it's not, you need to balance it correctly before proceeding. So granting that you've already balanced it, take note of the problem. It says that you're given if there's 30.0 liters of nitrogen that is formed at STP. Nitrogen means your N2 gas. How many moles of hydrogen will be produced at STP? So you've noticed that you're given volume of nitrogen gas, and then you also are given the condition that it is at STP. Now, because you're given the volume of your nitrogen and asked for the moles of hydrogen, then you have to begin with what you're given. So the 30 liters of nitrogen at STP, you can use your 22.4 liters is to 1 mole, or the PV is equal to nRT. The target is you have to get the moles of nitrogen from them. So the moment you get moles of nitrogen, then you can use the mole ratio of nitrogen and hydrogen. Use the mole ratio to get the moles of hydrogen. That's basically it. So you use 30 liters and the standard temperature and pressure values using your ideal gas law, or readily use the 22.4 liters is to 1 mole to get the moles of nitrogen. Once you get the moles of nitrogen, then use the mole ratio of nitrogen gas and hydrogen gas to get right away the moles of hydrogen. So pause this video, copy down the problem, and follow what I suggested you to do. And let me check the moment we meet if you got the correct answer or not. Okay, pause this video. Next, I will proceed to problem number 2. Let's read problem number 2. Do not solve this unless you solve problem number 1, okay? At standard temperature and pressure, what volume, so it's still at STP, what volume of oxygen, so that's what you're required, is necessary to completely react with 10.0 grams of hydrogen. So you're given 10.0 grams of hydrogen to form water via the following reaction. So the chemical equation is given here. And obviously the equation is unbalanced yet. So you have to balance this correctly. So even if water is mentioned here, but in this problem, you know that you're just given H2 and you are to get oxygen gas O2. So where do we begin? Because you're given the grams of hydrogen, the 10 grams of hydrogen, you have to convert it using the stoichiometry roadmap to moles of what you're looking for, which is O2. So that means this is a mass to mole conversion. The mass of hydrogen, which is 10 grams, you divide it by the molar mass of hydrogen first, then the mole ratio of hydrogen and O2. And right after that, the answer becomes the mole of oxygen. Once you get the mole of oxygen, you can use STP, standard temperature, and the standard pressure values, in which standard temperature is 273 Kelvin and the standard pressure is 1 atmosphere. Then you may use the ideal gas law to get V, which is nRT over P, in which you know N from the stoichiometry calculation, then R, then T, which is 273 Kelvin, and pressure of 1 atmosphere. Or, after getting the moles of oxygen from 10 grams of H2, you may just use the 22.4 liters is to 1 mole, then you will also get the volume. Whichever you're comfortable with and you can easily remember, then you do that. So follow what I just advise you to do, and you let me check the moment we meet in the classroom. So pause this video and answer problem number 2. And here is the last problem. This is a limiting reactant problem integrated in gas stoichiometry. It says that how many liters of water can be made from 34.0 grams of oxygen gas and 6 grams of hydrogen gas at STP. And then you're also asked, what are the limiting and excess reactants in this reaction? So first, the chemical equation is not balanced, so that means you need to balance it first. And right after balancing, because you're given two amounts, H2 and O2, you have 34 grams of this and 6 grams of this. That means you don't proceed to getting the liters of water unless you determine what is the LR and the ER. If you recall how we get LR and ER from the mass values, this is just going to be a mass to mole problem. It's mole until mole only because you just need the volume of water. The volume of water, we just need the moles of water. So first step is you need to convert your 34.0 grams of oxygen gas to moles water, and then second, the 6 grams of H2 gas to moles water. So common product, and then you compare which of the two will generate the smaller amount of water, and that becomes your LR. Okay? And that's the value that you will use to solve for the volume of water at STP. Again, you have two options to get the volume of water from your moles of water. Either you use the 22.4 liters is to 1 mole, or you may use the ideal gas law, PV is equal to nRT, in which you already know what's the value of the standard T and the standard P. So pause this problem and answer this third challenge problem on gas stoichiometry. Take note, every time you're answering and you tend to get stuck at a certain step, please take note what is it that you are not clear of so that we will know how we can help one another when we meet in the classroom. So please answer this correctly or follow the roadmap if ever you forgot. If ever you forgot the video on LR and ER, you may refer to it or you may refer to your textbook. So that's it for the last challenge problem involving gas stoichiometry. I hope you're able to answer all the three problems. It's really my expectation that you'll be able to find this helpful for you when you study at your own pace. Thank you so much. This has been Madam Narca saying don't stop learning, relearning, and unlearning, and do not ever give up because there's hope and no one can really tell when it's over. Thank you so much.